All right, ladies and gentlemen, it is officially the end of chapter 8 with your 8-6 notes. So let's take a look at that. It's very similar to what we did yesterday. What we talked about yesterday was exponential functions. Y equals a times b to the x power, where a could not be 0 and b couldn't be 1. Today we're going to go a little bit more in depth, and we're going to look at what happens when b is greater than 1 versus when b is less than 1 but still positive. So basically it's a fraction less than 1. When that b value is greater than 1, which is everything we did yesterday, you get exponential growth, and the graph looks like what you see here, which is what all of our graphs looked like yesterday. They all had that feature of staying above the x-axis just by a hair, and they went up slowly at first and then kind of shot up more quickly at the end, faster depending on the growth factor, or b. And they crossed this y-axis at point 0a. So we knew two things. We knew this, which was our growth factor, and we knew where it would cross given that x was 0. That is not changing. This is still going to be the 0a, same as before. What do you get when you plug in 0? That tells you where it'll cross the y-axis. But what's going to be different is that our b values are now going to be fractions, and so you can see that instead of growing from left to right, this is going to be decreasing, and so we call it exponential decay. So things that decay, or that doesn't have to be the word either. Like if you even think of the basketball tournament, you start with 64 teams, and then it drops down to 32, and then it drops down to 16 and 8 and 4 and so on. Anything that drops exponentially is going to have a graph similar to this one. So it's basically the flip-flopped version. You still see the same features. It still crosses the y-axis at A, and it still stays above that x-axis line, but it drops from left to right with the same general shape. So here, just to kind of see what this is going to look like in terms of your homework, it says tell whether the table represents an exponential function. So it could be growth or decay. If so, write a rule. Okay, so like yesterday, we look at the top and we see that each of these are going up by 1. On the bottom, though, you can see that you are not multiplying by a number and the numbers are not getting bigger. On the bottom, you're technically dividing by 5, but since exponential growth requires us to be multiplying, you're multiplying by 1/5, because 5 times 1/5 is 1. 1 times 1/5 is 1/5. 1/5 times 1/5 is 1/25. So just like yesterday, this is going to represent our b value. It's just that now our b value is between 0 and 1, which makes it exponential decay versus exponential growth. It wants us to write a rule. Well, aside from knowing b, I have to know a. And if you remember from yesterday, the place to find that is in the table. You look for where the x value is 0, and the number below it partnered with it will be your a value. So for us, in this case, it's a 1. So if I'm following that exponential model and my a is 1 and my b is 1/5, it would look like that. A lot of people will not write the 1 because multiplying by 1 doesn't change anything. So you might see it written just like this. And a lot of times with a fraction b value, they'll put parentheses so that you know the whole thing is raised to that x power. Not always, but sometimes. So let's take a look. Now we're going to practice graphing, knowing that our graphs, if it's exponential decay, should look like what we're seeing up here. It should look similar to yesterday's, but going down from left to right. So in this particular problem, the number that would be out in front is a 1. And so I can think, okay, my a is 1 and my b, which is the thing raised to the power, is 1/2. So I'm expecting decay because b is less than 1. I'm going to use my numbers from yesterday. If I plug in the -2, I would have 1/2 to the -2, which would flip that over and make it 2 over 1 to the +2. So that will turn it into a 4. If I have -1 as a power, I can flip that over and it becomes, excuse me, I didn't flip it over, I just said to. I could flip that over and have it be 2 over 1 to the +1, which would just be 2. If it's to the 0 power, 1/2 to the 0 power, anything to the 0 power is 1. Well, that matches what I thought I was going to get as my A value. And then here, they're asking me to plug in a power of 1. Well, 1/2 to the 1 power is just going to stay 1/2. And lastly, to the power of 2, that would square the top, which stays 1, because 1 times 1 is 1. And the bottom would be 2 squared, which is a 4. So these are the numbers that I'm going to be graphing. When x is -2, I'll be up 1, 2, 3, 4. When I'm at -1 on the x, I go up +2, 0, 1. When I'm at 1 for x, I go up only 1/2. And when I'm at 2 for x, I'm only going up 1/4. But all of that looks the way I think it should look, because it's supposed to be coming down pretty steeply and then really flatten out. And I try to draw that end neatly because I know that it's not supposed to curve back up. And I also know that it's not supposed to touch or drop down below this x-axis. Now this one wants me to graph them all on the same graph, so that's going to be a lot. So I'm going to go ahead and change this one to blue. And in the blue one, the difference is that I'm going to be multiplying my answers from before, because this part is the same, but I'm going to be multiplying each answer by 3. So I'm using my same values for my x's. I'm going to plug them in, but I'm not going to recreate all the work. I already did this 1/2 to the x part before. So I know that when I plug in a -2, this 1/2 to the x portion is going to have a value of 4 from over here. And so to do this new part, I'm simply going to multiply that 3 that they gave me by the 4 that I got when I plugged in 1/2 to the -2 power. So I end up with a 12. If you're confused about what I just did, instead of taking 3 times 1/2 to the -2 power, because I'm using -2 as my plug-in, then I would have had to flip this over to make this positive. 2 squared is 4. 3 times 4 is 12. I just took all of this from the work that I already did on the previous problem. So I can just multiply my answers from that previous chart by 3. So for plugging in a -1, I got a 2, but now I need to multiply that by the 3 that they put into this equation. My 0 before, when I did the 1/2 to the 0 power, I got a 1, but now I have to multiply that by the 3 that this equation has in it. When I plugged in a 1, I got out a 1/2, but I need to multiply that by my 3, so I get 3/2, which is 1.5 if you like decimals. And last, I have to take that 3 they gave me and multiply it by my answer that I had before, and so I get 3/4 or 0.75. So this one goes way off the chart. So at -2, this is 6, and I'm at 7, 8, 9, 10, 11, 12. I'm like way up here somewhere to get to this 12. At -1, I'm at least in sight. At 0, I'm supposed to be at 3. At 1, I'm supposed to go up 1.5. And at 2, I'm supposed to be down at 0.75. So this one is dropping and is a little steeper because of that A value being so high. Everything was tripled. Has the same shape, it's just a little taller. Then let's take a look at this last one. This last one sure looks tricky. The last one still has that 1/2 x that I got way back here in the first gig. But now I'm going to multiply the answers I had for that part by a -1/3. So if I use the same x's as I have been each time, I can take my -1/3 times the answers I got way back here. So that's going to be times a 4. So -4/3. Okay, then I need to put in a -1/3 times, what did I get before? A 2. So -2/3. I'm going to take my -1/3 from this problem and multiply it by the 1 that I got when I plugged that in. So -1/3. Again, my -1/3 times the answer that I got before. So -1/6. When I take my -1/3 times this last answer that I got before, I end up with -1/12. So a couple of things are going on here with this one. First of all, it has a number up front that's a very small fraction, and it's negative. So that actually is going to create a little different picture. So at -2, I'm going to go down 1.1/3. At -1, at -1, I'm going to go down to 2/3. At 0, I'm at -1/3. At 1, I'm at -1/6, 1/12. Obviously, I can't draw those any clearer. So I'm going to end up with a graph that's still coming in towards that 0 line, but now it stays below because that negative in the front did what it always does. A -A, like it does in every single graph, flips your graph upside down. So that is how this last one, this green one, ended up flipped over from the others, is that it had that negative out in front. The reason it isn't as steep is its A value was small. It was only 1/3 versus the blue one, which was steeper because its A value was a big number. It was a 3. So, excuse me, what we're looking for are those patterns. You want to be able to graph them. You want to remember that if the thing that you have raised to the power, if that B value is greater than 1, you're going to get the exponential growth we talked about yesterday. But if you end up with a value between 0 and 1, you're going to get the decay that we talked about today. And we just learned that if you have a -A out in front, that will flip your graph over. And it'll flip it over the x-axis. So it basically ends up upside down. So hopefully that makes sense to you, and you can come back and watch any parts of the video that you need. Good luck on your assignment, and that's a wrap on Chapter 8.